September 2012. A team at the University of Toronto enters an obscure image recognition contest called AlexNet. They submit a neural network. It beats the previous year's winner by 10.5 percentage points. The next best entry is closer to the runner-up than it is to them. Within 5 years, every NLP task on Earth had been redone with neural networks. Then in 2017, a single paper made everything else obsolete. This is the story of the 10 years that took us from computers can sort of recognize cats to ChatGPT. Last episode, the 1990s statistical revolution. IBM used Bayes' rule and a parallel corpus to beat every rule-based translation system. By 2005, 80% of the NLP conference papers were statistical. The empiricists had won, but everything in that era was shallow statistics, n-grams, log linear models, hand-engineered features. Deep learning changed what statistical meant. Instead of you writing the features, the network learns the features, layer by layer, from raw data. The trick had been around since the 1980s. What changed in 2012 was 3 things: more data, more compute, and one critical paper from Toronto. Today's 3 beats. First, 2012 to 2013, AlexNet, the trigger. Then Word2Vec, the NLP entry point. Second, 2014 to 2016, the RNN and LSTM era, sequence to sequence, machine translation gets reborn. Third, 2017 to today, the transformer, BERT, GPT, and the scaling moment. 2012, the ImageNet contest. Krzyzewski, Sutskever, and Hinton at the University of Toronto submit a deep convolutional neural network, AlexNet, trained on 2 GPUs in a dorm room. They beat the second-place team by 10.5 percentage points. The vision field changed overnight. AlexNet was a vision paper. The NLP field watched and waited. The opening came 1 year later, 2013, when a team at Google, led by Tomas Mikolov, published Word2Vec, a neural network that learned to represent every word as a dense vector of 300 numbers. And then, the magic. Vector math on those embeddings actually meant something semantically. The famous example: take the vector for king, subtract man, add woman. The closest word to the result was queen. Computers had stumbled into something that looked like meaning, without anyone telling them what meaning was. Word vectors were nouns. Language is sequences. You need a model that processes words in order, with memory. The 1990s answer was the Recurrent Neural Network, RNN, a network that fed its own previous output back as input. By 2014, an improved version called LSTM was running speech recognition at Google and Apple. It worked, but it was slow, and it forgot things over long sequences. In 2014, Badenau and colleagues added a critical trick on top of Sektuasuk RNNs. They called it attention. Instead of forcing the whole input sentence through a fixed-size bottleneck, the decoder could attend to specific parts of the source at each output step. Translation quality jumped immediately. The trick worked because language has long-range dependencies that RNNs alone can't track. By 2016, RNNs with attention had beaten statistical machine translation on every benchmark. Google Translate quietly replaced its phrase-based statistical system with a neural one in 2016. Most users never noticed the switch, they just noticed the quality jump. June 2017, 8 Google researchers publish a 4-page paper called "Attention is All You Need." They throw out the RNN, they throw out the LSTM, they build a model made entirely of attention layers, the transformer. It is faster to train, easier to parallelize, and beats every previous architecture on translation. The transformer is the single most important architecture in modern AI. Every major language model you've heard of is a transformer or a close variant. BERT, GPT, T5 Claude, Gemini, Llama, all of them. The 2017 paper has been cited over 100,000 times. It made the previous decade of architectures obsolete in 18 months. And then the scaling moment. 2020, OpenAI publishes GPT-3. A transformer with 175 billion parameters trained on roughly half the public internet. It writes code, answers exam questions, composes essays, all from a single text prompt. Nobody had fine-tuned it for any of those tasks. It just emerged from scale. By November 2022, OpenAI wraps GPT 3.5 in a chat interface and calls it ChatGPT. 100 million users sign up in 2 months, the fastest consumer product adoption in history. And here we are. From AlexNet 2012 to ChatGPT 2022, 10 years, 4 papers, 1 paradigm shift hidden inside 1,000 engineering decisions. 3 takeaways before the quiz. 1. 2012. AlexNet triggered the deep learning wave. NLP joined in 2013 with Word 12 vec. Vector math suddenly looked like semantics. 2. 2014 to 2016. RNN, LSTM, attention. Neural machine translation silently replaced statistical MT inside Google. 3. 2017. Transformer killed everything else. 2020. GPT-3 proved scaling was the lever. 2022. ChatGPT proved it was a product. Quiz 1. Which 2012 paper triggered the deep learning wave? A. Word 2 vec. B. AlexNet by Krzyzewski, Sutskever, and Hinton. C. Attention is all you need. Or D. GPT-3. B. AlexNet. The 2012 ImageNet win that opened the floodgates. Word to vec was the NLP entry point the next year. Attention was 2017. GPT-3 was 2020. Quiz 2. What did attention is all you need introduce? A. Recurrent neural networks. B. Word embeddings. C. The transformer architecture. Or D. Reinforcement learning from human feedback. C. The transformer. It threw out the RNN and LSTM entirely and built the model from attention layers alone. Every major LLM since is a transformer variant. Last quiz. What made GPT-3 significant? A. It beat humans at chess. B. It proved scale alone could produce qualitative new capabilities without task-specific fine-tuning. C. It replaced statistical MT at Google. Or D. It was the first to use word embeddings. B. Scale alone produced emergent capabilities. 175 billion parameters trained on roughly half the public internet, and it could write code and answer exam questions out of the box. No fine-tuning. The scaling moment. Back to the puzzle. LLMs produce sentences that are grammatical, contextually appropriate, and often factually accurate. They write essays. They translate, they debug code, and we still cannot agree on whether they understand any of it. The empiricists won the engineering. The CL question is back, and louder than ever. Next time, why language turned out to be the hardest problem in AI vision came first. Speech came second. Language was supposed to be next, and instead became the wall, the symbol grounding problem. Hit subscribe if you want it the day it drops.